Hi everyone, welcome to the next lecture of thermodynamics. So I hope you remember the last class where we discussed thermo 1 completely, right? So we can say thermodynamics 1 is completely over. So we will be starting our new topic, that is thermodynamics 2, that we will call it as solution thermodynamics. But other than whatever thermo 1 is there, right? So that every other topics will be there in the solution thermodynamics. Actually we don't have only solution thermodynamics. We have other topics as well. Okay? So I hope you remember every other topic, right? So as we did in thermo 1, first of all what we will do is we will write what are the topics we have. Okay? So I know kaun sa book use karna hai, that and all I have already explained several times, but still, alright, since it is the first class of solution thermodynamics, so your solution thermodynamics is for 4 to 6 marks in GATE. ठीक है, तो मैंने बोला था thermo 1 is for 2 to 3 या 3 to 4, right? So the remaining marks, major share of your marks is for thermo 2. ठीक है, so I'm calling it as solution thermodynamics to understand that it is for only chemical engineers. ठीक है, मतलब आप हमारा जो classical था that was combined with mechanical. Now from now onwards whatever topic we have is for only chemical engineering. ठीक है, so that's why that is the most important part. And कौन सा book use करना चाहिए? You have a Smith book. Right, Smith book is available. You can use K.V. Narayan book, right? So you can use any other book, right? So no problem. There is another book called Milody Koretsky, right? So this is a very good book for those who are preparing for interview, right? Once you clear GATE, like once everything is done, for understanding solution thermodynamics or chemical engineering part concept, you can use this book. Like all the books are available on the Amazon to buy, or you have you can easily get what I haven't seen this book's PDF, but the other two books PDF with solution is available. I don't know K.V. Narayan solution is available, लेकिन Smith का solution तो सबके पास available है, right? So it's not a problem. Now लेकिन Smith book, right, if you follow the order of the topics, right, it is somewhat difficult to follow, but in K.V. Narayan the order is very good. Like order in the sense हमें जो भी पढ़ना है ना, like GATE के हिसाब से, right? So GATE के हिसाब से they have given us syllabus, right? So the topics in K.V. Narayan is almost similar with that. That is स्मिथ बुक में आपको सर्च करना पड़ेगा, मतलब ये मतलब फॉर एग्जांपल मैक्सवेल कहाँ पे दिया हुआ है, मैक्सवेल इक्वेशन कहाँ पे दिया हुआ है, राइट? दैट इज गिव्स टू हम इक्वेशन, वेयर इज दिस पर्टिकुलर टॉपिक, दैट यू हैव टू सर्च इन स्मिथ बुक. बट इन K.V. Narayan it is given in order, that is 5, 6, 7, 8, like that chapter name is going with the flow, right? So it's very easy to understand. Okay, so before starting whatever we have learned in thermo 1, right, will have very small connection with thermo 2, right? We don't have much connection, right? And easiness of the topic, right? So कौन सा easy है, thermo 1 या thermo 2? समझने के लिए thermo 1 थोड़ा easy है. Like what is the meaning is, आपको याद रहेगा thermo 1 easily, मतलब work है, मतलब first law याद रहेगा, second law याद रहेगा, हीट मतलब हीट इंजन याद रहेगा, हीट पंप या रेफ्रिजरेटर, दैट साइकिल, सब कुछ आपको एक बार समझ में आ गया तो यू मे हैव दैट पर्टिकुलर पार्ट इन योर ब्रेन. दैट इज इट्स वेरी इजी टू अंडरस्टैंड एंड रिमेंबर. ठीक है, मतलब इंटरनल एनर्जी चेंज क्या होता है, लाइक एंथैल्पी, एंट्रोपी, दीज थिंग्स आपको इजीली यू विल रिमेंबर. बट द टॉपिक्स गिवन इन योर thermo 2 you may not remember sometimes, right? Still if I am teaching also sometimes I may get confusion, right? So in fugacity, that equation, what was that? ठीक है, and the problem, that is the only problem, because आपको sometimes याद नहीं रहेगा, और physically you may not be able to connect it, right? So maximum what we can do is we will try to connect it, right? That is we will give more examples so that आपको easily समझ में आए, right? That's what we are planning to do, right? And there are a lot of syllabus again in chemical engineering thermodynamics, that especially in solution thermodynamics there are a lot of equation, there are a lot of topics to study, right? But we are going to conduct this session strictly based on GATE, right? That is based on what are the questions they have asked previously from this chemical engineering thermodynamics or solution thermodynamics, and based on that question we are going to teach, right? We are not going to cover the entire Smith and Manners or entire K.V. Narayan book, right? It is not needed. We are going to cover only those particular topics which they have previously asked in GATE. Clear? So those topics will be discussed here, right? I hope you understood. Now some students may ask like, sir, there are some questions left for us to solve in Thermo 1. So some students ने मुझे question send किया है, right, Telegram group में या Telegram में directly also they have message. So that question also we will solve in between. ठीक है? Once we discuss some topics in solution thermodynamics, so if some students ask me doubt in Thermo 1, simultaneously we can solve and we can move on. ठीक है? So it's not a problem. And in solution thermodynamics, what are the important topics that I'm going to write? And we are going to have lot of equation. ठीक है? We are going to have lot of equations and daily you have to revise these equations, otherwise you may forget it, right? Or you have to see some method that, for example, Thermo 1 में भी मैंने यही बोला था, आपको equation याद नहीं रखना है, like you should know how to derive it. ठीक है? For example, if you know, like if it is a isothermal system, right, in a first law closed system, isothermal system, del Q plus del W. Right? If it is an isothermal system, ideal gas, this value will become 0. Then del W will be equal to minus P dV. Right? So then if you want to find the work, you will be integrating this P dV. Okay? So for P, you have to substitute PV is equal to constant C by V. So finally after integration, you will be getting minus C ln V2 by V1. So these things, there is no need to remember the formula, you need to know how to derive it. ठीक है? तो मैंने यही सेम चीज़ मैंने आपको एंट्रोपी के बारे में भी बोला था, फर्स्ट लॉ, ओपन सिस्टम, क्लोज सिस्टम, सब के बारे में यही बोला था, राइट? सो सेम वे यू शुड रिमेंबर हाउ टू डिराइव द इक्वेशंस फॉर Thermo 2. ठीक है? सो देन इट विल बी वेरी मच ईजी, राइट, टू रिमेंबर द थिंग्स. सो यू शुड रिमेंबर व्हाट आर द थिंग्स वी नीड टू स्टडी, राइट? सो देयर आर लॉट ऑफ टॉपिक्स इन Thermo 2. ठीक है? तो कौन सा टॉपिक्स पढ़ना चाहिए, राइट? सो व्हाट आर द टॉपिक्स वी नीड टू स्टडी, राइट? सो यू नीड टू टिक इट. Right, so that I will explain here, so don't worry. So what are the topics especially, or like for example अपना जो स्मिथ बुक है या केवी नारायणन बुक से क्या क्या पढ़ना है, because syllabus is very very lengthy. ठीक है? So in by this course what we are aiming is simple how to do problems in chemical engineering thermodynamics. And remember one thing, what I felt personally is when I was preparing for GATE, okay, what I felt is Thermo 1 क्वेश्चन कहाँ से भी आ सकता है, लाइक कंसेप्चुअल ओरिएंटेड क्वेश्चन आ सकता है, समटाइम्स मैकेनिकल पोर्शंस मिक्स करके क्वेश्चन आ सकता है, राइट? दैट इज स्टीम टर्बाइन, ऐसे मतलब कुछ टॉपिक से क्वेश्चन आ सकता है. वी कैन नॉट डू एनीथिंग. लेकिन Thermo 2 में क्या होता है नॉर्मली, इफ यू रिमेंबर ऑल द फॉर्मूला, इफ यू रिमेंबर ऑल द टॉपिक्स, ऑल द इंपॉर्टेंट थिंग्स, you can easily score 4 to 6. That is, out of 6 you can easily score 6 marks, right? Because like whoever attending this particular exam, right, everybody will not be remembering every formula in thermodynamics too, right? But if you are very good in thermodynamics too, if you remember all formula, if you know how to derive it, it is very easy to score 6 out of 6, right? But in Thermo 1 it is not easy to score out of 4 all the 4 marks. It is not easy. But in Thermo 2 it is very easy, right? So once you study this very well, it is guarantee that I can give you guarantee that is out of 6 you can score. Clear? So that is the speciality of Thermo 2. Even though you may not understand some points, right, even though you may not remember some points, for example, right, so sometimes they will ask you what is the relation with temperature, right, with respect to temperature and pressure, how a particular value is changing. For example, they may ask you fugacity, right, with respect to temperature and pressure. You may not be able to identify that, you may not be able to connect fugacity with temperature easily, राइट? फॉर एग्जाम्पल आपको एक प्रॉपर्टी में बताता हूँ, विस्कोसिटी. ठीक है? विस्कोसिटी ऑफ गैस या विस्कोसिटी ऑफ लिक्विड. ठीक है? तो इफ आई एम सेइंग व्हाट इज द रिलेशन बिटवीन विस्कोसिटी विद इंक्रीज इन टेम्परेचर, राइट, आप like you can easily imagine that viscosity concept with temperature of gases and liquids, right? So for example, in gas, what happens to viscosity with increase in temperature? For in case of liquid, what happens to the viscosity of liquid with increase in temperature? These things आप एक imagine कर सकते हैं ना. For example, what happens to viscosity of liquids if the temperature is increased? Right? Viscosity of the liquid will decrease. Right? Viscosity of the liquid, right? Viscosity of the liquids will decrease when we increase the temperature. How can we understand this? How can we keep this in the mind? Very simple, right? That is, whenever you are cooking something, right? Whenever you are cooking something, you are having some oil on the frying pan, right? When we are heating that, it will start to flow. Right? When we are heating that, it will start to flow. So the meaning is what? When the temperature is increased, the resistance to flow is decreased. That's why it is flowing. Clear? So these things we can easily connect. That is a speciality of what? Our fluid mechanics. राइट, हम इजीली कनेक्ट कर सकते हैं, मतलब फिजिकली थिंग्स के ऊपर वी कैन इजीली कनेक्ट इट, बट इन solution thermodynamics it is not easy sometimes, right? So that is a problem, so that also we will see. Clear? So these are the things we need to discuss. Now we will see what are the topics we have. Okay, now even though our topic's name is solution thermodynamics, मतलब आपके subject, if you see topic as solution thermodynamics, we normally start with what? Partial molar property. ठीक है, solution thermodynamics मतलब ही we are starting with partial molar property, but we haven't discussed the important part, so we have just completed thermo 1. So I will call this subject as thermo 2, okay, in terms of gate, right? I'm not talking about like thermodynamics, solution thermodynamics and all. I'm starting with thermo 2, right? Thermo 2 में हम क्या क्या पढ़ाने वाले हैं यहाँ पे, right? So that's what I'm going to discuss. So the first name of the chapter is, right, thermodynamic property of properties of pure fluids. So before entering into the solution, we have this chapter. This is our first chapter we are going to discuss. Right? I'm not starting the chapter today. Right? I'm going to give you what are the topics we have to take. That is, this can be a checklist for you. मतलब आप जब भी prepare करते हैं ना, you can tick it. These topics हो गया कि नहीं? Right? So that's what I'm aiming for this particular thing. So thermodynamics properties of pure fluid. This is our first chapter in thermo 2. ठीक है? So in this first topic you have is fundamental property relations. Right? You are going to have 4 fundamental property relations. इसमें तो 2 already we have discussed. What are the 2 we have discussed? If you remember, du is equal to TdS minus PdV. This is one we have discussed. Same way, dH is equal to TdS plus VdP. तो fundamental property relation हमारे पास we have 4, right? Out of that 2 is already discussed. ठीक है? अभी हमें 2 और चाहिए based on Gibbs free energy and based on Helmholtz free energy. ठीक है? So we have 4 equations, fundamental property relation. Before discussing that, right? First 2 already cover किया ना, हम thermo 1 में ही cover किया है. ठीक है? I hope you remember. Now the next 2 we are going to start in the class. Clear? So this is our fundamental property relation. So this is our first topic you need to remember in thermodynamic properties of pure fluids. ठीक है? So this is our chapter 1. I can say this is our chapter 1 in thermo 2. So in this you have to study first fundamental property relation. Then from fundamental property relation you have to study Maxwell's relations. You have 4 Maxwell relations. ठीक है? So this you might have done in your college, right? So this is a normal question that is for 10-15 marks. I have done that, right? Okay, मतलब हमारे college में thermodynamics, this is always a question in your university exam, that is explain all the fundamental property relation and derive the Maxwell relation from that. Clear? This was the question normally. Clear? So this is used to be the 15-16 mark question. ठीक है? So Maxwell relation. So remember, you don't have to remember any relation, any Maxwell relation and all. Simply the thing is, you should know these 4. So from these 4, how to derive it, that we can study. Right? How to remember it, you can study. Clear? So for that, some shortcuts are there always. So that shortcuts also we will teach. ठीक है? So this is our first 2 topics you need to remember. ठीक है? So what are the topics? First one is fundamental property relation. You may have, you will be having 4 fundamental property relation. Then you will be having Maxwell relation, right? Or Maxwell equations also they will say. The third is, we will say, Clapeyron equation, and also you will be having Closius-Clapeyron equation. I don't know whether my spellings are correct or not, but these are the 2 topics you have to go through. Clear? So Closius-Clapeyron and Clapeyron. These are the next 2 topics we have in this. So why I am discussing this is because in this chapter itself you have lot of syllabus is there. Right? If you see the Smith and Madness book, or if you see the K.V. Narayanan book, if you see Koretsky book, any book, right? You are having vast syllabus. Right? But from that syllabus, what are the important topics I am saying? So when I am saying important topics, right? So normally क्या होता है? Like after every class, the message is, sir ये काफी है क्या? Like is this enough sir for gate? Is this enough sir for gate? like the thing is we cannot predict the gate question first of all, right? It depends on you यार, मतलब आपको अगर PSU में रैंक चाहिए तो other than the class you have to prepare extra, right? So everything we cannot teach, right? So whatever we are teaching here is based on what? Last 20-25 year question paper, right? So whatever we teach here, that will be enough for maybe for solving last 20-25 year question paper plus some extra question. ठीक है, सो आपके साइड से भी एफर्ट चाहिए, लाइक यू शुड नॉट आस्क लाइक सर इतना काफी है क्या, इतना काफी है क्या, पहले ये तो करो ना, राइट? सो फर्स्ट यू हैव टू डू वॉट एवर वी आर टीचिंग फर्स्ट, देन गो फॉर द एक्स्ट्रा पार्ट, राइट? सो देन ओनली लाइक व्हाट यू विल हैव द कॉन्फिडेंस ऑफ अटेंडिंग एन पर्टिकुलर पेपर, ठीक है? वी विल नेवर नो, दैट इज एवरीथिंग इज इन द सिलेबस, राइट? गेट में क्या होता है नॉर्मली, राइट? इफ यू रिमेंबर लास्ट टू लास्ट ईयर, नॉर्मली यही होता है, सिंपल थिंग. There was a topic in fluid mechanics called similitude. There is a topic that is similitude. ये syllabus में add किया है 2020 में, right? In GATE 2020 they added similitude in the paper, right? In your fluid mechanics syllabus. लेकिन 2019 में ही एक question आया था similitude के ऊपर, ठीक है? So how? Because पहले वो लोग 2019 में क्वेश्चन पूछा है, राइट? जो दे हैव आस्क्ड अ क्वेश्चन इन 2019 व्हेन एवरीबॉडी टोल्ड सिमिलिट्यूड इज नॉट इन द सिलेबस, इन 2020 दे एडेड इन द सिलेबस, ठीक है? ऐसे भी हो जाता है गेट में, लाइक दैट इज नॉट लाइक यू कैन नॉट से सर ये सिलेबस में नहीं है, वी नीड द मार्क्स. सो गेट में ऐसा नहीं होता, यूनिवर्सिटी एग्जाम में मे बी दैट मे हैपन, right? That is, it is not in the syllabus, so out of sympathy people will give you some marks, that is the faculties will give you some 2 or 3 marks in your internals sometimes. But in GATE ऐसा नहीं होता है, right? If you say it is out of syllabus, next year they will add in the syllabus, right? So you should not ask like sir this is enough or not, right? So first finish this, then you can go for the other topics. So पहले important topics पढ़ो, उसके बाद you can go for the next topics. Clear? So this is the point I am making. Now you have some rules also after this thing that is not so important, that I will explain you in the last. So after Clapeyron equation and Closius-Clapeyron equation, they have asked previously some questions in these two. Clear? So once these two is over, you have what? You have based on some other property also they have asked previously, coefficient of volume expansion, that is beta, and compressibility or isothermal compressibility we can say alpha, right? So these based on these also they have asked question, ठीक है? और आप ये भी देख सकते हैं, ये coefficient of volume expansion, this term beta you will study in your heat transfer in convection, ठीक है? convection में you will study about beta. And fluid mechanics, isothermal compressibility, bulk modulus of elasticity, this isothermal compressibility is 1 by bulk modulus of elasticity. इसके बारे में you will study in fluid mechanics also, ठीक है? और मतलब हम यहाँ पे भी thermodynamics में भी we will be discussing both the terms, ठीक है? So you cannot say like gate में if they are asking based on alpha, right? They can ask from fluid mechanics connected question, thermodynamic connected question, right? Beta means it is there in heat transfer also, so they can ask anywhere, thermo, heat, right? Meaning is same, right? If anyway they are going to ask in gate, right? So it's not a problem, ठीक है? So this is also another topic you need to discuss in this particular chapter. Now once this is done, right? Once this is done, you have the topic of the topic, right? The important topic called fugacity, right? So all the above may not be required for the next chapter, right? I'm not talking about the gate. पहले जो भी हमने डिस्कस किया है 1, 2, 3, 4, राइट? इसका उतना यूज नहीं है आगे, मतलब वी मे रिक्वायर ओनली द इक्वेशन ऑफ डीजी इन द अपकमिंग क्लासेस और अपकमिंग सेशंस. लेकिन fugacity in the first chapter has very much application in the upcoming chapter, मतलब अपना next chapters में we have the use of fugacity. So we will define fugacity, right? And we will write the equations of fugacity, right? So these things will be done in the first chapter, that is in your thermodynamics properties of pure fluids in this chapter. Then you have 3 methods for calculation of fugacity, right? You have methods for calculating fugacity. Methods for calculation of fugacity. You have 3 methods, right? You have 3 methods. One is based on compressibility factor, right? So that those kind of method, that is we are having 3 methods, okay? So that 3 methods also you need to remember, right? क्योंकि maximum question from fugacity has been from methods, राइट. सो फर्स्ट चैप्टर से बोल रहा हूं मैं, ठीक है. फर्स्ट चैप्टर से मैक्सिमम क्वेश्चंस इस टॉपिक पे आया है, राइट. दैट इज कैलकुलेशन ऑफ फ्यूगैसिटी बेस्ड ऑन दिस मेथड्स, ठीक है. सो दैट इज वन टॉपिक. क्लियर? I hope you understood. So these are the major topics you need to remember, right? These are the major topics in our first chapter, right? So even though there are two rules, right? There are two rules. One is known as Troughton's rule and another rule known as Watson's rule, right? You know Shane Watson, right? So Watson's rule, right? Watson's and Troughton's rule, right? These two rules are there, right? Even though in GATE so far they haven't asked, I have seen some questions in your PSU exams, right? ठीक है, मतलब अपना जो भी एग्जाम्स है, अदर एग्जाम्स अदर देन गेट, राइट. केमिकल इंजीनियरिंग के लिए जो भी अदर एग्जाम्स होता है, राइट. सो इन दैट PSU एग्जाम्स लाइक वैशाख स्टील हो या VSSC एग्जाम हो, राइट, विक्रम साराभाई स्पेस सेंटर, दीज काइंड ऑफ एग्जाम्स, राइट, अदर एग्जाम्स, राइट, अदर देन गेट. सो इन दोज these two rules are necessary, right? Because if these two rules, it's very simple, because if you remember two formula, right, Troughton rule or Watson rule, easily एक दो question solve हो सकता है, directly application of formula, right? So if you know formula, that's all, ठीक है. So ऐसा भी question आ सकता है. So this is our first chapter, ठीक है. I hope you understood about first chapter. Clear? So here we will be defining all the basics. Clear? Now we are starting what? Our second chapter. So actually our second chapter's name is Solution Thermodynamics. Clear? So up to this, in the first chapter we have to discuss pure fluids. Now we are entering into our second chapter called Solution Thermodynamics. So once again, those who are watching the video, right, I haven't started any topic yet, right? So those who are watching just now, right, I haven't started any topic yet, right. I'm just listing out the topics so that आपके preparation में it will be a help, right? So whenever you prepare, right, you can tick it, okay, I have solved these, I have prepared from these topics, that's enough, right? So this is the meaning. So solution thermodynamics, the most important topic is partial molar property, PMP. That is your partial molar property. In this you have to find partial molar volume of component 1, component 2, like that, right? You will have equations, right, in a binary mixture, calculate this. Based on this you might have lot of problem, right? If you see 20-year question paper, right, most of the questions are from this partial molar property. So whenever, right, so if you didn't study anything and if you are going for a particular exam, right, like GATE, right, so the first thing is every time, right, if you don't remember any other equation, always remember partial molar property concept and the problems, because most of the time out of the 4 to 6 marks, this chapter alone, that is the partial molar property alone, may give you 2 marks, ठीक है. So that happens, right? So the partial molar property, so base calculations are very much important, right? So इसमें से questions normally आता है, right? So you have to remember partial molar property. So this is the first topic in your solution thermodynamics, right? So we have entered the solution thermodynamics. In this, the first topic is partial molar property. In that itself, you have almost, we need to discuss lot of things in partial molar property, right? So in this, next is here in the same chapter we will be teaching chemical potential, right? So conceptually chemical potential we need to study this thorough, right? This have application in what? Your mass transfer also, right? Mass transfer पे भी we will be using chemical potential, ठीक है. So हमारा जो solution thermodynamics है, it has direct connection with your मास ट्रांसफर, राइट. सो मास ट्रांसफर में जो भी इक्विलिब्रियम डाटा सब कुछ, राइट, यूज होता है ना. सो दोज थिंग्स आर कनेक्टेड, राइट. सो वी विल डिस्कस अबाउट दैट कनेक्टिविटी एज वेल, ठीक है, सो दैट यू विल अंडरस्टैंड बेटर, ठीक है. मास ट्रांसफर में यू मे नॉट रिक्वायर दिस, राइट, लेकिन इफ यू कनेक्ट दीज टू सब्जेक्ट्स, सो इट विल बी ईजी टू अंडरस्टैंड द प्रॉब्लम, ठीक है. सो दैट ऑल्सो कैन हैपन इन एग्जाम्स, राइट. दे कैन कंबाइन 2 subjects and they can ask question, right. Last year there was a combined question from CRE and heat transfer. Clear? Same way also they can ask like that also. So that is the meaning. Now next, once these 2 topics are over, you have third topic called fugacity of solution, right? Fugacity of solution. In this you are having Lewis-Randall rule, you have Rolle's law, you have Henry's law. Now if you understand these three laws, right, that is three laws are very similar, right, very easy to understand. आपको अगर condition समझ में आ गया, right, so what is the difference between these three laws, right, it's very easy to understand. ठीक है, so always generally हमारे class में, right, what we are going to discuss will be, right, a mixture, that is two solutions, right, or that is two liquids are mixed, liquid solution it can be, right, that is for example I'm mixing alcohol plus water. Alcohol is component 1, water is component 2, so we have two phases, liquid, vapor, right, so solute in liquid phase, right, vapor phase, these kind of terms will be coming. So we will be applying all these three rules to this particular mixture, alcohol water mixture, so it's very easy to understand. Okay, so I will be connecting practically and it will be very easy, right, it will be interesting to learn these three law connecting with the mixture. Clear? So this is our important topic, and as I told, right, most of the questions are from PMP and these, right, so it will be very easy to understand the things. Now once these things are done, right, once these things are done, you are having some equations, right, so conceptually we will finish everything here, then it's all about mathematics, right, so it's all about maths. That is, you will have topics like Gibbs-Duhem equation, Gibbs-Duhem equation, and we have topics like property change of mixing, property change of mixing, right, and we are having some excess property. So you can, if you want, you can write these things, right, so these are the topics we have, right, so excess property or these things, property change of mixing and Gibbs-Duhem equation. So these are the topics mainly we discuss in this chapter. ठीक है, so most of the questions तो इसमें से आता है, right, so Gibbs-Duhem equation you have some form, right, so if you remember one or two equations, very simple. ठीक है, maximum आपको कितने equations होंगे, remember, like if you may have to remember maybe 10-12 equations, right, but if you remember one or two equation, you can easily derive every equation. That's the speciality of Thermo 2 as well. ठीक है, that is, if you remember, if you didn't remember any equation, you can derive it from the starting, right, if you have any confusion. Clear? Because if you remember that equation, it's very easy to solve the question, so it is worth deriving. ठीक है, अगर एग्जाम में अगर आपको वो एक इक्वेशन याद नहीं है, the question may be of 2 marks. ठीक है, so importance of Thermo 2 is, right, out of the 15,000 students writing the exam, right, out of the 15,000 students writing the exam, those who attempt Thermo 2 questions are always maximum is 1,500 only, right, so this is what we know already, because normally students, जो भी serious students होता है ना, they only will prepare this Thermo 2, otherwise students will not study every topic in Thermo 2. ठीक है, so 2 marks from Thermo 2 is very much important, क्योंकि सबसे toughest questions for every students will be from Thermo 2, right, because tough हम किसको बोलते हैं, right, so normally maximum students, the questions which is not attended by maximum number of students is the toughest question, simple. ठीक है, so maximum students तो Thermo 2 attend ही नहीं करते हैं, right, so if you have time, derive the equation and find the answer, and if you get 2 marks, no other students, right, so if you see only 1,500, out of this 1,500, only maybe 500 students will get the correct answer of Thermo 2. Clear? So if you get 2, you are getting 2, right, and your friends are not getting anything. That's the importance. Clear? So this is the point, so remember these things. Now once this chapter is done, right, once this chapter is done, third chapter is our phase equilibrium. Phase equilibrium is very simple chapter, that is, these 3 laws, everything is connected to this phase equilibrium, right, it's very simple chapter. So if you remember one equation, right, one equation is enough. That is, the questions based on these chapter can be easily solvable if you remember one equation, right, and if you understand the application of this equation, that is gamma I xi pi power s is equal to, this is your fugacity coefficient into yi into p. तो अगर आपको एक इक्वेशन याद है, right, if you remember one equation, right, if you remember one equation and if you understand the application of this equation, Majority of the problems here are connected with this equation. Easily solve कर सकते हैं, right? Fugacity coefficient, activity coefficient, xi, pi power s, yip, right? Everything is simple. ठीक है? So if you remember these things, shortcuts, it's very easy to understand. Clear? So this is about what? Your phase equilibrium, and the last chapter, the fourth chapter, is chemical reaction equilibrium, right? Where you will have questions based on what? Extent of reaction, that is your epsilon, right? Epsilon based questions also you might have seen. Okay? So chemical reaction equilibrium is a very small chapter. In the same chapter, mixed, you have what? You have a topic, degrees of freedom, right? Always confusion topic, right? Degrees of freedom. Okay? So degrees of freedom also will come in between these two. Okay? So these are the total topics we have in your thermo, right? So I hope you remember. So we'll be starting with our first chapter, right? What was our first chapter? Our first chapter was thermodynamics of pure fluids. So you have all the basic things covered in that, plus solution thermodynamics, right? In this we will discuss this much, then phase equilibria, chemical reaction equilibria, then last over. Clear? So these are the total topics you have in thermo, that is total important topics, right? So if you ask me, right, if you ask me for example, sir itna kafi hai kya, right? The answer is very simple, right? The topics in your syllabus is, for example, is solution thermodynamics, one word, thermodynamic properties of pure fluids, that's all. In that thermodynamic property chapter, everything given in Smith question they can ask, Smith book they can ask, right? So we cannot say that is not in the syllabus. But the thing is, what we are going to do is, we will see the syllabus, right? We will see the previous year question, then from the question we will decide what are our topics. Clear? So that's all, right? So that's our important part in solution thermodynamics. So we will be starting our first chapter, right? Our first chapter we will be starting from tomorrow, right? So we have some time. So some students have asked me doubts in the last class, that is doubts in the sense some previous year gate question that we will solve now, right? So with that, right, so this is the introduction. So today's lecture is only the introduction and the important topics, that is the list of things we are going to do from the next class, right? And we will discuss that, right? Before that, we will complete what are the small topics left, or some questions are there, previous year questions, that is before 2004 some questions are there, that we will do in the class, right? So that that also will be completed. So one of the question asked by our student, so the starting of the question is not available with me, so I will read that question, right? So I don't have the question in my question printout, so I will read the question, okay? So you can understand it, okay? So there is a heat exchanger, okay? There is a heat exchanger is given. So in a parallel flow heat exchanger, the question I am reading, in a parallel flow heat exchanger operating under steady state, hot liquid is entering and leaves at a temperature is given, and also cold fluid is given, right? So there is a hot fluid and cold fluid, and they are saying neglect any heat loss to the surrounding, and they are saying which one of the following statement is correct. That's all. Clear? So this is the point, and they have given 4 options. So out of the 4 options, which will be correct, right? That is option A, entropy gained by the cold stream is greater than entropy lost by the hot stream. Okay, now entropy gained by the cold stream is equal to entropy lost by hot stream. Entropy gained by cold stream is less than entropy lost by hot stream. Entropy gained by cold stream is 0. So which one will be correct? So we have already discussed the same type of question previously, right? So I hope आपको answer आया होगा, right? So always the total entropy should increase, right? So always the entropy gained by the cold stream will be greater than entropy lost by the hot stream, right? So when there is a heat loss, right? When there is a heat loss from the hot stream, right? When there is a heat loss from the hot stream, the entropy of the hot stream will decrease. Okay, so entropy lost by hot stream. When there is a heat transfer, cold stream will be gaining some entropy. So total entropy is increasing. So option A is correct. Clear? So I hope all of you got the answer. So this is the next question. If the temperature of saturated water is increased infinitesimally at constant entropy, what will be the resulting state of water? Liquid, liquid vapor coexistence, saturated vapor, or solid? Tell me the answer. If the temperature of saturated water is increased infinitesimally at constant entropy, resulting state of water will be. So if it is constant entropy, what is the meaning? Constant entropy meaning is the process should be what? adiabatic, right? Reversible adiabatic, that is there is no heat transfer. Clear? Or constant entropy meaning is what? There is no heat transfer, right? So when there is no heat transfer, what will happen? What will be the phase change? There will be no phase change, right? That is, phase change happens when there is a heat transfer, right? If the system is at constant entropy, what is the meaning? There is no heat transfer. So if the heat is not given to the system, the liquid will never change to what? Vapor, right? So our saturated liquid will remain as what? Liquid only, right? It will remain in the liquid state, right? Unless if you give heat, right? If you give heat, what will happen? Liquid will convert to vapor, right? लेकिन अगर हम कुछ नहीं दे रहे, right? So we are not giving any heat. At constant entropy, what is the meaning? If it is constant entropy, we are not giving any heat. So what will be the state of the system? It will be liquid. Clear? I hope you understood. This is the next question. 2005 IIT Bombay. Carnot heat engine cycle is working with an ideal gas. The work performed by the gas during adiabatic expansion and compression steps are W1 and W2 respectively. So what is the answer? Right? Adiabatic expansion and compression steps, IIT Bombay, that is Carnot heat engine cycle is working with an ideal gas. Clear? I hope those who want to read the question, please pause the video and read it. So it's a very simple question, right? So there is an ideal gas and they are asking Carnot heat engine cycle is working with an ideal gas, okay? And work performed by the gas. So we need to find the work done by the gas during, right? Or work performed by the gas during adiabatic expansion and compression. That is, you need to find what? Adiabatic compression and adiabatic expansion. During that, what is the work? Clear? So both cases you need to find. So it's very simple. This is adiabatic expansion. This is adiabatic compression. So if you remember, जब भी हम expansion करते हैं, what will happen to the temperature? Temperature decrease or increase? When we are expanding, what will happen? Temperature will decrease. When we are compressing, temperature will increase. Clear? So when it is adiabatic, we cannot transfer heat, right? So compression meaning is your temperature will increase from TL to TH, right? आपको Carnot cycle याद होगा ना? TL to TH. Expansion है तो क्या होगा? Temperature TH to TL. तो आपका initial temperature है TH, फाइनल टेम्परेचर है TL इन एक्सपेंशन. एडियाबैटिक कंप्रेशन में क्या है? TL to TH. सो फर्स्ट लॉ इक्वेशन क्या है? दैट इज du इज इक्वल टू del Q प्लस del W. du इज इक्वल टू del Q प्लस del W. कौन सा टाइप ऑफ प्रोसेस है? एडियाबैटिक. सो del Q कैंसल्ड ऑन बोथ. आइडियल गैस है तो व्हाट इज द इक्वेशन ऑफ U? U इज CVdT इज इक्वल टू del W. du is CVdT. So what is the work done in this case? It will be integration of CVdT from TH to TL. यहाँ पे what will be the work? It will be integration of CVdT लेकिन from TL to TH. So अगर ये आपका W1 है, ये आपका W2 है, what will be the relation? Only आपका what has changed? Limits interchange हुआ है. So you can say what? W1 will be equal to minus of W2. Clear? So this is another question based on this Carnot cycle. So I hope this doubt is also clear. So next question is GATE 2002, right? That is, steam undergoes isentropic expansion in a turbine from 5000 kilopascal and 400 degrees Celsius. Entropy is given to 150 kilopascal and entropy of saturated liquid, entropy of saturated vapor is given. The exit condition of steam is, they have given superheated vapor, partially condensed vapor with quality of 0.9, saturated vapor and partially condensed vapor with quality of 0.1. Right, so those who want to read the question again, please read the question by pausing the video. So this is the question in GATE 2002. So as I've already told you, right, so before 2004 हमें mechanical topic से connected questions आता था, right? So that is, for example, entropy in steam turbine and all. After 2004 we don't have any question from turbine, right? So compressor, etc. questions are not there, right? So whatever questions we have after 2004 does not deal with these topics from mechanical engineering. But steam turbine, since they have asked before, आपको ये याद रखना पड़ेगा, that is for steam turbine we will get maximum power output in a steam turbine, right? We will have maximum power input in a steam turbine when we are having isentropic expansion in a turbine, right? So we will be getting maximum power output in a steam turbine, right? Steam turbine, right? When we do isentropic expansion. What is the meaning of isentropic expansion? Reversible adiabatic. Clear? So this is the meaning. This point you need to remember it, right? This point you need to remember. Now this point has no connection with this question, but in the other question they can you can relate it. Okay, so this is the meaning. Now, so whenever you see maximum power output, आपको ये समझ में आना चाहिए, that is the expansion should be isentropic, right? So what is the requirement of turbine? Turbine is used to produce the power. Clear? So I hope you can understand. So I will read the question. Steam undergoes an isentropic expansion in a turbine from 5000 kilopascal. I will write the given value from 5000 kilopascal, and 400 degrees Celsius is what? 673 Kelvin, and entropy is given 6.65 kilojoule per kg Kelvin, right? So this is your first condition, that is inlet, right? This is your inlet of the turbine, right? Now to 150 kilopascal. So you can see expansion meaning is pressure is reduced. Clear? So entropy of the saturated liquid is given. Entropy of the saturated liquid is given 1.4336 kilojoule per kg Kelvin. And entropy of saturated vapor is given 7.2234 kilojoule per kg Kelvin. What is the exit condition of steam? That's what they are asking. Clear? So this is what they have given. Clear? Up to this is fine. So initially steam undergoes an isentropic expansion from 5000 kilopascal and 400 degrees Celsius. So entropy of the steam, right? So this is your entropy of inlet, right? If it is an isentropic expansion, right? If it is an isentropic expansion, your entropy of the inlet should be equal to what? Entropy of the outlet. Clear? Right? Clear? So when they give you steam entropy at the inlet is this much, right? So this may be what? Saturated. Right, but here when you have liquid, saturated liquid and saturated vapor means here you should find what? Quality of the steam. Right, here at the exit you have to find the quality of the steam. So how can you find the quality of the steam? Right, so if you want to find the quality of the steam, you need to find the entropy at the outlet. Clear? You need to find the entropy at the outlet. So read the question and understand how to find the outlet. Clear? So find the value. So how to find the quality, right? So how to find the quality? So you can see what will be the entropy here. If you know entropy of liquid and if you know entropy of vapor, how can you find the entropy? Very easy. I hope you remember. Quality into entropy of vapor, that is I can denote it by what? G plus 1 minus x into entropy of liquid, that I am representing it by fluid F, gas. Now the same equation, if I multiply this, if I expand this, entropy of the fluid plus, right, entropy of the fluid plus minus x into this and plus, so it will be x into, it will be entropy of the gas minus entropy of the fluid. This will be the equation of what? Entropy. Now, if it is an isentropic expansion, outlet entropy and inlet entropy should be same. So what is the inlet entropy? It is 6.65. Substitute it, 6.65. What is the liquid entropy? It is 1.4336. Quality, we don't know quality, X. What is gas entropy? It is 7.2234 minus liquid is 1.4336. Calculate कर लो X की value from this. Right, so do the calculation and find the value of X and check the option. Option क्या क्या दिया है? Superheated vapor. Right, superheated vapor is option A. Option B is partially condensed vapor with quality of 0.1 and partially condensed vapor with quality of 0.1. So find the value of X. So I think आपको आंसर आएगा 0.9. X is equal to 0.9. मतलब क्या है? Steam has 90% of vapor, 10% of liquid. Clear? 90% of vapor and 10% of liquid. So quality of 0.9. So your option B will be correct. Clear? So this is the way we will be solving. Right? So I hope all of you are getting. Right? So only thing you need to remember is in a steam turbine. Right? So remember in a steam turbine, whenever they say maximum power output, right, it should be an isentropic expansion, right? It should be an isentropic expansion. You need to remember this. So isentropic expansion means the entropy in and entropy out both will be same. Done. So we'll go for the next. Next question is in the next year, that is 2003 IIT Madras. On the same page, okay. A steam turbine operates with a superheated steam flowing at 1 kg per second. This steam is supplied at 44 bar and 500 degrees Celsius and discharges at 1.01325 bar and 100 degrees Celsius. So please pause the video and write the data, okay. Data at 41 bar, 500 degrees Celsius, enthalpy is given, entropy is given, okay. It is a superheated steam at 41 bar and 500 degrees Celsius. And then at 41 bar and 100 degrees Celsius, they have given enthalpy of saturated steam. Enthalpy of saturated steam, let me check the question once again. So, okay, it is entropy, okay, correct. Enthalpy of saturated steam is given, entropy of saturated steam is given. Now, at a different pressure, that is 1.01325 bar and 100 degrees Celsius, they have given enthalpy of saturated vapor and entropy of saturated vapor. Right, so both have given, and saturated liquid is also given, and entropy of saturated liquid is also given. So these are the data given. Clear? So I hope you understood. Now the question is the maximum power output. You need to find the maximum power output. Options are given. So find the answer. So first of all, we will write the given value, right, for a steam turbine. So first of all, they are asking, what is the question, right? Question is maximum power output. So first of all, लास्ट क्वेश्चन ऑल्सो मैंने बोला था, ठीक है. तो जब भी whenever they are asking maximum power output, ठीक है, so it should be an isentropic expansion, especially in the case of a steam turbine. So first isentropic expansion, right? ठीक है. So first I will write the given value on the board, then we will solve. Let me write the given value. First of all, we'll see that. So it's a steam turbine. Clear. So mass flow rate is given. Mass flow rate is 1 kg per second. Yes. Steam is supplied at, so inlet conditions and outlet conditions are there. So I am writing the inlet condition. Steam is supplied at 44 bar. So 44 bar steam is inlet condition. Okay. Inlet condition. Now 44 bar and 500 degrees Celsius, that is 773 Kelvin. Now discharges at 1.02. So outlet or exit conditions is your outlet is 1.01325 bar. So obviously it is exiting to the atmosphere, okay, and temperature is 373 Kelvin. ठीक है, so you can see it's an expansion, right? It's an expansion. Now 41 bar and 500 degrees Celsius means this case the enthalpy of the inlet, right? Enthalpy of the inlet is 3443. It's in kilojoule per kg, okay? Entropy of the inlet 7.0785 kilojoule per kg Kelvin. Now 41 bar and 100 degrees Celsius, right? So it is not at okay, this they have given, it is 44 bar, okay? 44 bar. In the question also there is a small printing mistake, I guess. So it should be 44 bar, okay? Because in the question they have given 44 bar, so the data should also be in 44 bar, okay? So now at 44 bar and 100 degrees Celsius, right? 44 bar and 100 degrees Celsius, the data is given. Enthalpy of the saturated steam, right? Enthalpy of the saturated steam, Hg is 2799.9. Now entropy of the saturated steam, Sg, is 6.0583. Now at the exit, enthalpy of saturated steam is, saturated vapor, right? Saturated vapor is 2676 kilojoule per kg. Enthalpy of saturated liquid is 419.1. Entropy of saturated vapor, that is entropy of saturated vapor Sg, is 7.3554. And finally entropy of liquid is 1.3069. In GATE, don't write the given value if it is very lengthy, right? See the monitor and solve, right? So this is a classroom, that's why I am writing, right? That's why we are wasting that such time, right? No problem. Now they are asking what? Maximum power output. So you should know maximum power output in a steam turbine will be always when it is an isentropic expansion. Just now we have told. So entropy of the inlet should be equal to entropy of the outlet. Right, so this is the first point you need to remember. First of all, what is the equation for maximum power output? Right, I hope you remember application of first law of thermodynamics into an open system. ठीक है, क्या equation था? d by dt of mass into specific your internal energy of the control volume plus it was outlet minus inlet of mass flow rate into enthalpy plus kinetic energy plus potential energy equal to heat transfer plus work transfer. हमने ऐसे एक कंप्रेसर का बेस क्वेश्चन किया था, स्टेडी फ्लो डिवाइस, ठीक है? स्टीम टर्बाइन स्टेडी फ्लो डिवाइस मतलब इफ द ऑपरेटिंग कंडीशंस आर नॉट चेंज फॉर अ लॉन्ग पीरियड ऑफ टाइम, यू कैन कंसिडर इट एज अ स्टेडी फ्लो डिवाइस, ठीक है? सो योर स्टीम टर्बाइन, राइट, इज ए स्टेडी फ्लो डिवाइस. सो यू कैन इजीली cancel d by dt too. Clear? Kinetic energy, potential energy can be neglected, right? So and heat transfer normally it should be 0, right? So generally your equation for work output of a turbine, right? Your work output of a turbine is generally, you can see here, it should be mass flow rate into outlet enthalpy minus inlet enthalpy. Outlet minus inlet, H2 minus H1. So this should be, right, so this should be your equation. Clear? So this should be your equation for what? Your work output. Clear? I hope you can understand this. So what we need to find is, हमें inlet enthalpy पता होना चाहिए, outlet enthalpy पता होना चाहिए. These two we need. You know, inlet is what? Inlet is, first of all, if you read the question once again, inlet is superheated steam. Superheated steam मतलब क्या है? Right, that is in your superheated steam they have given the enthalpy of the superheated steam. So H inlet you already know, entropy inlet you already know, लेकिन do you know the enthalpy of the outlet? नहीं पता, क्योंकि you don't know, right, because you don't know the quality at the outlet. मतलब You know superheated steam expand हो रहा है, right? And it is becoming what? A mixture, right? Liquid vapor mixture हो रहा है, right? It is expanded into an liquid vapor mixture. So you should know the quality at the outlet. Without quality, आप ये H2 you cannot calculate. Clear? So for finding quality, आपको पता है, if it is maximum work output, your entropy at the inlet should be equal to entropy at the outlet. What is the entropy at the inlet? It is, I am writing it, entropy at the inlet is equal to 7.0785. It should be equal to what? Entropy at the outlet. So how can I write the equation of entropy at the outlet? Entropy at the outlet should be equal to X into, that is quality at the outlet, multiplied by entropy of the gas or vapor plus 1 minus X into entropy of liquid. Simple, solve kar lo ye, right? That is 7.0785 is equal to, what is the entropy of liquid? You know 1.3069, that is the outlet entropy, plus it will be what? Entropy of the gas minus entropy of the liquid multiplied by X. You know entropy of the gas, you know entropy of the liquid. Solve and find the value of X. What will be the value of X? Solve and find the value of X. So according to the calculation, your X will be 0.9542. 0.9542 will come out as the quality. Is it fine? Right? You will be getting X is equal to this as the quality. Complete it. Now you have the enthalpy at the inlet, but you don't know what is the enthalpy at the outlet, right? You don't know enthalpy at the outlet. So how will you calculate enthalpy at the outlet? So check the given value, right? क्या क्या values दिया हुआ है, right? You can check the values given, then find it. It's very simple, right? How to find the enthalpy at the outlet, that is H2, that is same equation, enthalpy of liquid plus enthalpy of gas minus enthalpy of liquid minus multiplied by X. Every value is given. What is HF? HF is there, 419.9. What is HG? HG, for that they have given a value HG at 100 degrees Celsius. That is, आप यहाँ पे देख सकते हैं what is the change between these two data. ये दोनों डाटा में what is the change, right? क्या डिफरेंस है? This is the data for superheated steam. So ये आपका superheated steam है. Superheated steam condense हो गया तो क्या हो जाएगा, right? If the superheated steam condenses, it becomes what? Your saturated vapor. Right? If we release heat from superheated steam, what will happen? It will become the saturated vapor. So this is the saturated vapor, right? This is your saturated vapor, right? So this, I hope you remember, we have drawn this particular diagram like this. Water at 300 degrees Celsius and 1 atm. Water at 300 degrees Celsius and 1 atm is superheated water, right? Superheated steam, right? अगर आपको कंडेंस करना है, so what you will do? You will bring this 300 degree Celsius water to 100 degree Celsius water. Then it will become what? It will become saturated vapor. Now from the saturated vapor, you will release heat. Then you will become what? Saturated liquid. फिर से heat release किया तो सब cool liquid. ठीक है? So use all the value and find the value of H2. X का वैल्यू ऑलरेडी हमने कैलकुलेट किया है, राइट? सो यूज इट. सो व्हाट विल बी HF? HF इज 419.1 प्लस HG इज व्हाट? 2799.9 minus 419.1 multiplied by X. You will get the value of H2. So once you get the value of H2, what will be H2? It is 2572 point something. H2 is 2572 point something kilojoule per kg. You know H2. What is H1? H1 is 3443 kilojoule per kg. right? So calculate it. Mass flow rate is 1 kilojoule per second. Multiply, you will get the answer, right? You will get the answer in minus, but all the options are in positive, so you can calculate it, right? So what will be your work output? So the answer is, I hope your answer is what? 871.22 will be your answer. 871.22 kilowatt, right? If you want to avoid confusion, you can take it as inlet minus exit, right? So this equation is based on our sign convention, right? That's why we are getting minus, because work done by the system is negative for us. That's why we are getting negative. Your answer is 871.22. Clear? So this is your calculation based on entropy. Or questions here, right? So you have more questions, right? These kind of questions after 2004 they haven't asked, क्योंकि steam turbine and all we don't have that much in our chemical engineering. That's why they don't ask nowadays. But if they ask, you should be able to solve, because even though it is a 2004 question, before 2004 question, it is in your chemical engineering, right? So try to understand this, try to solve this. Clear? So that is the end of today's lecture, right? So next class we will start the topics, that is your Maxwell relation and your fundamental property relation. Those things we will discuss in the next class. Okay? And within 1 week, right? So we are going to start live classes in YouTube. That is, now I am stuck in my home. That's why I am not able to take the live classes. That's why I am doing the recorded. So we will be starting within 1 week, right? So I hope the lockdown is getting lifted, right? So in Raipur, so mostly we'll be hopefully, right, we can start from next week, right, in YouTube live. Okay, live ho sakta hai. So that's why, right, I'm going somewhat slow here, right? That's why we can, because in live class we can take more than 1 hour. Okay, we will get more than 1 hour, so that one topic can completely we can complete it in one class. Clear? So we will finish everything soon. Okay, so wait for the live class also. Okay, that's all. Thank you.